Welcome to CADRE. In this session, we'll focus on applying computational thinking to our work in actively designing and researching equity. Before we dive into this video, let's review the black box we talked about in our first video and how it's used in problem solving. As you'll remember, when we frame problem solving as a black box, we begin with a set of resources or inputs, conduct steps that apply those inputs towards a solution, and obtain some output or result. From a computational thinking standpoint, the black box is the code. Typically, if the output produced is different from what's expected, revisiting that black box is a great place to correct bugs. The black box approach is a powerful tool because it combines critical thinking and problem-solving skills, allowing us to develop and refine our solutions over time. Applying this approach to education puts us in a strategic position to identify bugs in our processes. This approach will allow us to address gaps in student outcomes.
That same computational thinking is applied to our work in CADRE. We have inputs, the process, and outputs. For our work, the output is you, the educator. Our goal as educators is to be able to develop students' learning outcomes, their cognitive, academic, social, and emotional skills. Research has shown that these learning outcomes lead to increased student performance. As educators, the impact we want to make is that every student actualizes their fullest potential. The input is also you and what you already have. Don't wait for your district to buy new things or implement new policies. Identify your circle of influence and bring an equity mindset as you create meaningful relationships with your students and colleagues. Now, before we code inside that black box, let's go through each step in the equity cycle. Our core goal is to develop the intellectual capacity of students. That's developing students' academic, cognitive, social, and emotional skills. We know there's gaps here, which means there are barriers to this. Our job is to identify barriers to student learning. We do this through empathy interviews with students. It only takes 10 minutes and you only have to connect with 3 to 4 students. The goal of the empathy interview is to center students' lived experience by listening to their feelings and acting on what we can do to help. And that's our output. The output is changing our behavior to better support student learning. Start with small wins. What micro movement can you do to better develop students' learning behaviors? I've been doing interviews with students for the past 25 years, and I found that micro movements from teachers, even ones as simple as following up with students, make a big difference in students feeling valued and seen. This increases student attendance, attention, and retention of knowledge. Then we go to the inputs. In the CADRE framework, the inputs are outlined for you. Rather than thinking we need more of this or that, like more money, more policy changes, more diverse teachers, know that you are the greatest input and asset. Remember your circle of influence and focus on bringing an equity mindset to that. The final step is going inside the black box, where you'll code, run, and debug your code. Identify your educator output and the data you'll collect on your performance. We're trained to collect data on students, not ourselves. In CADRE, we want to focus on our impact on students. That's the data you'll collect from your reflections and empathy interviews with students. Now you're going to run your code by implementing your lesson plan and collecting your data.
Have you noticed that in most of our digital devices, we have to keep updating the software as new versions are released? This is largely because over time, development teams fix bugs, add features, or implement safeguards that make our devices more secure. In the context of the work we're doing, we have to do that too. Anytime our expected outcomes don't align with the actual outcomes, use it as an opportunity to go inside the black box, debug your code, and run it again. We can improve if we don't debug our code. Putting this all together, applying computational thinking to equity requires centering student experiences. You'll factor in the resources available, develop your code, run it, and continuously debug it. This way, our intended outputs will match our actual output. Now it's your turn to cycle through equity. We're excited to see your progress. Let's blast off to equity.